happen over some sort of networking. Second, we need to talk directly peer-to-peer between RGB node and send information about assets and transfers. And there are a few other cases. Well, the design of the architecture we are doing for RGB node and as well for Lightning node and Bitcoin indexing node is microservice architecture. So we have a lot of internal communications happening between different daemons and threads. And it all comes down to transfer of information and sending requests. So we faced this problem of constructing a protocol, a peer-to-peer protocol. Do you see my slides?
Yes.
Yes.
A P2P protocol, and we actually quite soon understood that, first of all, we don't want to design a new protocol, another protocol. The second, the problem is very common. It's not only we who face the problem with RGB, it's also a lot of different other things, like for watchtowers, we need some API. For future discrete log contracts, we need networking part, and here some guys present who are working on both of these projects. Lightning network extensions, when we will move further with the channel factories and other functionality, we have to extend the existing Lightning network protocol in an efficient way. I said we will need P2P and RPC APIs for RGB, and in future probably we will create other protocols. So it's a common task. And it's not only about protocols, it's also about products, because for Bitcoin and Lightning nodes, we hope that one day we will have better RPC protocol, client-server protocols than current JSON RPC, which is really outdated. And more projects like to follow microservice architecture, like C-Lightning, for instance, did. And for that, they also need and require some efficient way of API design, not spending time on inventing new protocols over and over again. So that's why we take some effort, because the RGB effort is a part of this LNP-BP standardization attempt, an attempt to create a standards on top of Bitcoin and Lightning network for building layers, layer 3 application and so forth. So we took this effort to find the best possible way of doing a networking protocol for peer-to-peer environment. And we started with and today I would like to present what we have designed to share this information and to invite all of you to collaborate, to use these things, to write your critics, questions, and hopefully we will make life of everybody working on layer 2 and layer 3 applications easier. So I will start with general design principles and the analysis that we've made. Basically, what networking consists of? By networking, I mean not only communications through the network, I mean any communications even inside the same machine between different between processes or threads. So what these communications are made of? First of all, we need some encoding protocol to represent the data. Usually in memory, we have these data structures, which can be hierarchical. And when we send it over some channel, we need to encode them in a linear structure, in a byte sequence. This is called serialization or encoding. We need transport protocols, which take care of framing, encryption, session management, and other tasks. And we need some standard for procedure invocation. What are possible standards for procedure invocation? These are classes of application program interfaces. Basically, it is, first of all, it's peer-to-peer. Lightning network is using peer-to-peer, and Bitcoin using peer-to-peer networking interface called Bitcoin via protocol. It's the situation where two equal peers, two equal nodes, have to share some information. And basically, they send some information over to another node, particular destination, and they don't wait for some form of response. They can just receive subsequent messages back after that. It's the way the Lightning node actually works and Bitcoin node works. And I will name these protocols briefly P2P in the further slides. There are RPC protocols, more convenient. It's basically what we call client-server interaction. They have asymmetric roles. So there is a client connecting to a server, and client sends requests to a server and waits for a server reply. There is a set of REST protocols, which is basically serve the same idea as RPC. It's client-server communication protocol, but comparing to RPC, when in RPC we have this imperative style, when we name some procedure and provide arguments and then get something in return. In REST, we name some resource by some URL, your universal resource locator, and we get data about that document. I wouldn't talk and cover this part here today because they mostly have a web application, and any web application can be made with RPC, so we decided not to invent something in the sphere of REST for now. And the fourth type of the interface API is a publication subscription. It's another way of communicating with asymmetric roles, but unlike client-server communications, there is a publisher and multiple subscribers. And publisher publishes some information to all of these subscribers. And subscribers do not have any possibility to send any information to the publisher, at least within the scope of this protocol. They can use some other protocol to communicate. So we need some protocol that is able to cover at least three of these cases. Peer-to-peer, because we will have a peer networks, and the nodes have to be able to communicate in that environment. We also need RPC for any client-server communications, like command line tools or wallets calling to a server for some data and information, like Bitcoin wallet calling Electrum or Bitcoin Core or Lightning node. And it would be nice to have something for publication subscription APIs. At least Bitcoin Core already implement that for with a zero message queue to deliver information about new mined blocks and new transactions. And it would be nice to have ability to support this type of communications as well. Through our analysis, we worked through this all three families, like encoding standards that exist on the market, and we made a comparison between them basing on the transport protocol use, languages supported, code generation style, speed, security, interoperability. The actual transport framing protocols, again, we made a comparison between them, and remote procedure call protocols and RESTs. I wouldn't go through all the analysis here. There is a GitHub issue covering this analysis, and also we will share the presentation afterwards. So all of you who are interested in details may look into these slides. What requirements did we had when we made this analysis? First of all, we would like to move to a Tor-like networking IDs and to get rid of the necessity of using SSL and DNS. It's basically the way the Lightning Network did, and unfortunately we don't have the same with Bitcoin node. The problem with the IP addresses, DNS names, and SSL certificates that they basically issued by centralized parties. And these parties are in some way controlled by governments, and they can be used to censor part of the communications. So the Lightning Network P2P network protocol was one of the first protocols, and of course Tor itself, which had found a way how to abstract from these entities and being able to make you can self-generate a node identifier, like a domain name. Basically, it is a public key. So you create some private key, and you derive a public key matching that private key, and this public key is identifier of your node. And you use both public and private key to encrypt the traffic with any other node. And by doing that, you are able to get rid of SSL and DNS altogether. So we need some protocol that is actually working in the same way. We need this protocol to be able to route traffic through these multiple peers with this new type of identifiers, because if we will use just a normal IP routing, we will again be exposed to all the censorship problems of the modern internet. We have to maintain all traffic encrypted, always. It should not be an option. It should be the only way of having communications. Again, like with the Lightning Network today, there might be some cases like inter-process or inter-thread communications on the same machine when we do not need to encrypt the traffic. And we need to clearly distinguish that so that all the traffic that gets into a public internet always be encrypted. These protocols that we will choose for networking, they have to be able to natively work with the hashes, public keys. It's a problem for many existing protocols like protobufs and Apache Thrift, which are not support efficient way of encoding this native Bitcoin world data types. And the protocol has to have already a user base, a community around it. So when we were selecting all those protocols, we can't put something new on because we don't have time to create a new libraries and to create a community supporting this new protocol. And the protocol have to be suited for both P2P and RPC cases, and hopefully for publish subscribe case. And it also must work over Tor, and it also must work with a zero message queue or other systems for microservice, modern microservice architectures. And it also must work with WebSockets so people will be able to create efficient web applications. So a lot of requirements. And at the end of the day, we found that existing frameworks, which usually consist of transport layer, of encoding layer, and of some RPC standards, all these frameworks that are widely used for web applications and then application development, they basically don't suit our needs. They don't work with Torah-like structures, or they required to have a DNS or SSL, or they can't be routed, they can't be encrypted, and so on and so forth. So we have to throw Open API, Apache Thrift, Google Protobufs, Apache Avaro, WAMP, this WebSocket-based standards. And the only protocol that we left is actually existing Lightning P2P protocol, because it still doesn't fit all our needs, so we can't use it in the current form for RPC, we can't use it with WebSockets or zero message queue, but at least it supports the rest of options. So what we started doing is we started looking into Lightning Network Protocol, how it can basically be extended to be more universal protocol, covering all the requirements that we have. And we started with this architecture. It is architecture of Lightning Network Protocol stack proposed by C.Decker. And we see that there is quite a good layerization of transport and base networking protocols, so we can extract that things at least. Well, so in order to design this protocol, the protocol for this universal networking, we called it LNP, Lightning Network Protocol. It is based on existing Lightning P2P protocols defined in Bolt 8, Bolt 1, and Bolt 9. We taken these protocols and dissected them into separate layers. I will be showing later which are these layers. Added support for WebSockets and zero message queue, added support for remote procedure call type of communications and publish subscribe APIs, and added some encoding enhancements. So we ended up with this universal networking protocol, hopefully for that Bitcoin world can use. It's both both decentralized and encrypted, and interoperable. This slide just summarizes what I already said, so I wouldn't go through all the details. Again, you can, if you need more particular information, you can look into this slide later after the presentation. And that's basically was the approach that we took. Unfortunately, it wasn't that simple because while we have very efficient architecture, the actual specifications, how they define those protocols is not that good layered. So that's why I said that first we had to start with the dissection of existing Lightning Network standards and also libraries, because we did the same job for Rust Lightning library, and dissect them into these layers. So maybe those of you who had experience with the networking development, you know these OSI network layers. It's a standard by ISO organization that defines the networking protocols. It is used by TCP/IP, Internet, and so on and so forth. So in terms of these OSI network layers, we always have a transport layer. And for transport layer, we took a Lightning Network Framing Protocol. It is an extract from Bolt 8. It is not the whole Bolt 8, because Bolt 8 also covers a session layer for encryption, handshake, and node identifiers. You see it on the second layer. But the other part of Bolt 8 covers the structural framing of Lightning Network messages. And that part we extracted from Bolt 8 and defined as LN Framing Protocol, or LNP-bp 18 standard. Additional to this protocol, we have developed a WebSocket embedding and zero message queue embedding of the same protocol. So the session layer, which deals with encryption, node identifiers, and handshake, establishing the actual encryptors and public and private key structure for communications, which is another Bolt 8 extract called LNP-bp 15. It can not work only on native Lightning framing, but also over the WebSockets and over zero message queue. So already at this layer, at this stage, with this layerization and dissection, we got the advantage that we can route the native Lightning traffic on top of WebSockets for web applications or zero message queue for inter-process communications within the same machine. Next, we define the presentation layer, which actually structures how the Lightning network message is built of. It is a combination of some part of Bolt 1 and Bolt 9. Basically, it defines that there is a message type, which is 16-bit integer. There are some ranges for this message type. There is some encoding for the message data. There could be an additional TLV stream with TLV records. These all parts became part of this LNP-bp 19 standard, which is used by the next layer, application layer. And at this layer, the native Lightning Network Protocol defined in Bolt 2 and some parts of Bolt 1 works on. But additionally to that, we were able to build a generic RPC protocol and particular applications for RGB and related service and other stuff and other services like watchtowers or DLCs and others can be built at this application layer with quite simple and straightforward API, which I will describe over the next slides. So we have this layerization being made, again, some technical details about each layer and how it works for your later consideration. And the most probably the biggest change that we had to introduce is that normally Lightning Network uses some style of encoding, of data encoding, and it's not well defined in any of these bolts right now. Namely, we have each method defines the encoding of the data, and it's not very well designed, let's say. that way. So while we were working on RGB, Peter Todd made a big contribution by defining rules for a strict serialization which is robust and which can avoid many pitfalls that usually happens with a network protocol development. So we took these rules, which are actually that I will run through them quickly on this slide. So do not ever compress the data, because we are not talking about gigabytes of traffic. We are talking about RPC and P2P messaging. So don't compress the data. Use deterministically defined value lengths. And Bitcoin Lightning Network var int style integers is a very bad practice. So we would like to avoid it. Again, because current Lightning Network already use them, they will remain at that places, but any other RPC or P2P protocol designed, which is not part of the Lightning Network, it should avoid using that encoding. The lower and upper bounds both have to be well designed, and the party that receives the message must validate against that bounds. And if the value is not fitting into the bounds, it must reject the message, because this can avoid many attacks, networking attacks, and reduce the attack surface of the protocol itself. And in terms of lower and upper bounds, we are not talking about the number of occurrences of some item. Like, for instance, you can send several occurrences of an item, but also a range for a possible value. So in case of strings, we must define the bounds for string lengths. So the string shouldn't be greater than 1,000 bytes, for instance, and bounds for the characters within the string. For instance, we can limit them to be ASCII characters only, or not limit, but again, these have to be well defined for each message and for each field. And we shouldn't use any pointers, offsets, shifts within the data structure, and no linked lists. Fortunately, Lightning Network messaging follows to a certain degree of these standards. So we have no other option than just to allow existing messages in Lightning Network, but as a part of LNP networking standards, we strongly recommend that all new messaging types will follow these standards. And for that reason, we, with Christian Decker, have started to work and designed a way to define the API. Again, we don't want to invent a new standard. Today, C-Lightning already uses inter-process communications, and they defined a CSV format for describing this API, which they apply both for Lightning Network messaging and for internal communications. So we wrote a parser that parses that CSVs into any verbose text format. These are YAML, JSON, and TOML. They can be converted into each other, and basically you write a definition of the API using one of those standards. It's looking like this on this slide. So you define some types that you use, bindings for different languages, messages with their number identifiers, and actual parameters that are used by this message. And you can add these bounds that I was just talking about, limiting the allowed values for each type, for each field. And all of that for current Lightning Network protocol and C-Lightning inter-process communications can be automatically generated from existing code. And of course, if you design a new protocol, a new type of node for your own purposes, you can write these descriptions and again use them to automatically generate the code. The idea that amount of auto-generated code should be really small, and who is interested, I will guide you through how it is done. So you are all welcome to check this tool set on GitHub. You see the link on the right side. And you can, it's not completed yet, so me and C.Decker, we are working on its completion, and you are welcome to join to contribute into its development. Hopefully, well, it's already being used for RGB stuff. It will be used for C Lightning upgrade, so it will be merged into the master at some point of time, hopefully. And again, I invite all of you who are working on watchtowers, DLC, P2P messaging to join this route so we can save the time for developing actual business logic instead of designing over and over again the same networking layers. And also we are using it, maybe you heard about that, we are doing a Lightning node, Rust-based Lightning node called LNP, and Bitcoin indexing node and RGB node, they are all using these standards already. So I already showed how it looks in YAML. There is also an attempt to find a less verbose than YAML or JSON way of defining in that interface. We called it LIDL, less verbose interface definition language. I'm not sure still, do we need it or not? So it's a draft attempt of what can be achieved with that. Comparing to YAML, first of all, it's more readable because you clearly see the bounds on the number of items and allowed values. You can use a very efficient language-specific customization of bindings of types and values. You can use multiple files, unlike in YAML or JSON. You can't reference external files and data structure from external files. You can do it with this way, and it can be used to write formal deterministic API spec for both for lnp-bps. Actually, this protocol definition is a formal definition of what the node should accept, should reject, and how it should behave. So we would like to welcome your feedback to see whether this attempt is required. Basically, when you define this API using this little language, it will be converted into YAML or JSON definition and then into the code. So basically, we are still not inventing the new language. We are inventing a more efficient way of writing specification and defining a standard for some API. So outside of RGB and Lightning Network, how you can use all of that? Well, basically, I already said, but some interesting potential application is that you can build a messenger which works outside of existing Lightning Network with this P2P protocol or even client-server protocol, which will have an end-to-end encryption, which can use a Lightning invoices or LSATs or Lightspeed payments. And it can be end-to-end encrypted even if there is a central server is present. So it can work over Tor and mesh networks from day zero. So it unlocks a lot of potential. There is also a proposal to move Bitcoin Core RPC on this protocol, de facto this protocol, because basically any protocol designed in the same way as Lightning Network P2P protocol will be automatically compliant with this interface definition, code generation tools, and standards. The only thing, it will be able to be ported on top of WebSocket, Zero Message Queue, and the rest of interesting stuff. The only thing that we advise is to follow the strict encoding rules, not to follow the rules that are used by current bolts, which are less strict. And this LNP protocol, as we name it, is a kind of soft fork extension to existing Lightning Network P2P protocols, enabling them for different types of networks and transport layers. So there is few proposals existing. I already mentioned this Bitcoin Core RPC proposal, and there is also a Bolt 13 proposal for watchtowers. Basically, they are already compliant with this standard. So we basically create a tool set and toolbox that will simplify the development and finalization of such protocols and simplify the programming for implementation of these protocols. I already told that there is multiple transport layers that can be built with this generalized Lightning Network protocol. Lightning Network, original Lightning Network is working over TCP/IP or TCP/Tor combination natively, and we propose to use it by default whenever you like, whenever you need network communications, either P2P or RPC communications. However, if you use inter-thread communications, inter-process communication, or you're building a microservice architecture, you're trying to design something like enterprise service bus, everything that happens in demilitarized zone beyond the firewall, it can utilize many advantages of zero message queue. And for such communications, which can be P2P RPC or publish subscribe, we propose to use zero message queue as a transport layer. If you build a web apps that have to run from web browser, you have to use WebSockets. And in this case, you can use WebSockets, again, with the same encryption that is used, noise escape encryption that is used by Lightning Network Protocol. Potentially, we haven't finished this part yet. You can use UDP for running the communications. It can be required for low connectivity situations like mesh networking and satellite. And C.Decker, he is also thinking about using SMTP as a transport for ultra low connectivity. He would like, for instance, to make Lightning payments working over blockstream satellite. And for that reason, SMTP can be quite a good solution. So there is another work by C.Decker done in this direction. So network communications can extend into the domain of mesh networks, satellites, or even some offline cases when you just print it out, some message as a QR code, and pass the messages through QR codes if required. So for sure, you need to select and specify somehow which transport layer you use. And for that reason, we designed a number of URL schemes that indicate the support of this protocol. Here are details how you can encode that. And there are some recommendations. Already I covered them in a table, but you can reference the textual explanations as well. And hopefully, this network protocol that I presented is a first step towards generalized Lightning Network protocol that will allow very extensible and configurable Lightning Network channels. Of course, it have a lot of applications outside of Lightning Network, like we are doing for RGB. It can be potentially applied for other P2P networks, for DLCs, and so forth. And we hope that with the appearance of applications using LNP instead of other networking protocols, we can fix some problems introduced by naive TCP/IP design and this requirement censorship coming from DNS and SSL services. That potentially can help that build more censorship-resistant internet. And I'm saying that what we need to do is to build Internet 2 using LNP-BP standards and not Web3 as built by blockchain, so-called blockchain community with these fluffy ponies and a lot of censorship coming at the different levels on top of internet itself. So the Internet 2 is focused on confidentiality and censorship resistance, and we hope that LNP can be a tool for that. And hopefully one day it can make its own way as an addition to TCP/IP into POSIX operational system kernels, and maybe one day even Bitcoin and Lightning nodes will become a part of that kernels as well. So it's kind of big vision which we would like to follow and to promote others to believe into, because it is the only way we can move towards more confidential and censorship-resistant internet. So let's work together on this stuff. Here are some links. First of all, it is a current Rust implementation. And this Rust implementation can be used from many different languages. So you can basically compile it as a binary, library, and link from Node.js and others, the way we do with the RGB. There is a sample usage code, how you can use this protocol. It is the way we use it in our own RGB daemon for communications, and other nodes will follow soon, so you can also take example from there. There is a set of tools to generate interfaces and code. Here is the link. And of course, all parts of this system of LNP-BP standards are written as standards. So the Rust implementation can be not the only one implementation. And you can help writing your own implementations and again, code generation for other languages from the interface descriptions. That is all for the networking protocol. I think I have the second part, which is more about RGB integration into wallets, exchanges, and so on, which showcases also the LNP use. But I think we will leave it for the next time because we already like 40 minutes and we need some time for questions and answers.
Thank you, Maxim, for the presentation. I think now it's a good time to have a sort of Q&A session, especially while I see Chris and other guys here and Nadav and others present here. Can you give some feedback on what you've seen just now? It would be very, very helpful for us to know whether it works for you guys, whether it is helpful or not.
I'd just like to comment that there are a couple of proposals for the future Lightning Network, like stuck list payments and some stuff with these things called barrier escrows that I think have a lot of unknowns surrounding their networking stuff right now. Like stuck list payments, for example, requires some kind of communication between the payer and the payee that isn't necessarily well defined right now, and I think it would be really cool to see that fleshed out in kind of this LNP context, because it looks like it would probably be a good use case.
Yeah, that could be. It would be interesting to talk to the guys who are doing that. If you have their contacts and the links to these standards, please share, and we will discuss with them use of this protocol.
I guess the question that I have is there like a demo video or I'm on the page right now of the runtime.rs stuff that you link to. I mean, is there like a getting started guide or like 5 steps to run an example or something like that?
Unfortunately, not yet. It's a product of the May. So we've done that with the C.Decker throughout the May. And I think in next couple of weeks, more materials will appear that will help other developers to use it. But basically, if you intend to do something with it, the best way is just to say me, and we will create some materials for you, and then for sure make it public.
Yeah, I mean, I guess I'm just trying to. It'd be nice if there's like some examples or something that you can kind of grok to get an idea of what exactly is what it's capable of, or what the state of the implementation is, I guess.
Yeah. Right now, the description is this presentation that I just gave, and for sure there is some documentation and comments, and there is RGB node that is using it, but throughout the next few weeks there will be much more. So we will continue sharing with the community, with the same community, all this stuff.
I would like to have some general comments. I know it's not really the goal of anything. I mean, privacy is not really the goal of anything, but did you consider to have very strict requirements regarding message formats, like even what kind of line endings can you add there, or limiting the white spaces that, okay, here white space has to be and here white space cannot be. That would improve fingerprinting with multiple implementations.
The protocol is binary, and it has even current Lightning protocol. It puts restrictions on the messages, and there is no such cases that you can either have or not have white space. So everything is well defined. With this protocol, it goes even further. So you define the length of the data structure. You define the bounds for the values of integers. So even if you're using, for instance, 32-bit integer, you still can limit that it shouldn't be greater than some particular number or shouldn't be less than like 100. And if it is outside those bounds, the party that received this message, it must reject the message. So it's not even white spacing, it's much more stricter. So you can't, by that you reduce many potential attack vectors, and you increase the robustness. And also, if you looked into Lightning message description, there is very verbose. After each message, you have a big section saying that the node should reject if that happens. Now it's all algorithmical, and it helps to both write the specification, to do the implementation, and make sure that the attack surface is reduced as much as possible.
All right, thank you.
Thanks for the question, Adam. Thank you guys for commenting. I actually think that Maxim, can you give approximate estimate on the second part of the presentation?
Well, I have a limit by the time here, so I have to end in 15 minutes strictly, so we wouldn't be able to finish this part, and we have to do that next week, because it will take at least another 40 minutes.
Oh, okay, okay. Okay then. It's just
basically,
yeah. There are a lot of guys from wallets here now, and maybe for them the RGB integration would be of more interest than the.
Well,
Lightning.
I can cover a few slides from the presentation then, which are well, I can do a brief version of the presentation.
Yeah, maybe just some hints, some insights for the guys that are not familiar with RGB as a tech and they want to implement it at least at some point. Maybe just quick review would be helpful.
Okay, and plus I will showcase how the LNP protocol can be used in product design, like RGB node and wallets and communications.
Yeah.
So okay.
Yeah.
Okay, let's do that. Just give me a second. I will again share the screen. Do you see it?
Yes.
Okay. We have, well, you probably know what is RGB. It's a smart contract set of protocols that allow smart contracts, including the digital assets, and not only assets, everything else, what we can do with the smart contracts on, and it can be working on a Lightning network. It is very confidential. It uses client-side validation, so it doesn't store any data in blockchain. It uses the best of zero knowledge from developments of Blockstream, basically Pedersen commitments plus bulletproofs and so on and so forth. And what we are doing is we're creating a software stack for exchanges and wallets to integrate with, and all components in that software stack already using LNP protocol to communicate with each other. What are these layers? Basically, RGB is working on top of Bitcoin network and Lightning network, and there is also an RGB network used for transfer of client-validated data. I will briefly cover what kind of nodes are involved in these networks. On top of that, we have a bottom layer, the very core of the system, which is lnp-bp core library, written in Rust. It's very we put a lot of efforts into making it well peer-reviewed and audited. And LNP protocol is actually implemented as a part of this library. So if you look into Rust LNP-bp repository in our organization GitHub, you will see the directory for BP is Bitcoin protocol extensions, and LNP is this networking protocol. On top of that, we have a layer, an integration layer, which allows you as a wallet to use different storage drivers. So the library manages the storage for yourself. And it is compatible with the mobile wallets, with the web wallets, with the server side solutions. And you can plug in different types of storage drivers depending on the conditions and your software requirements. On top of that, you have more high-level abstractions specific to RGB schema. What is schema? It's basically a type of contract that you are using. For instance, fungible assets will be a schema, and there will be a library, and there is a library to work with the fungible assets for you as a wallet. You can think about the schema as a kind of IRC. So fungible assets is IRC 20 type of stuff. We even named the standard defining the schema RGB 20, just to be consistent with the rest of the market, and just because we know that RGB will be used for many scam tokens, so we had to select appropriate name. And there will be other types of schemas like collectible, identity schema, and others. And on top of that, you can build your own wallets or RGB related nodes, or do an exchange or payment provider integration. What wallet types are possible with RGB? First of all, it's 3 wallet types. It's not the same classification that is usually which most of people use, so I will clarify a bit. First of all, you can have several serverless wallet, which is non-custodial. So you keep the private keys in the wallet itself on the client device, or outside the wallet on the hardware device, or in cold storage. This wallet is fully validating. So it does all the validation. It is possible with the client-side validation paradigm. It's much more harder to have a full Bitcoin node running on mobile device, but it's much easier to have a full RGB node running on this device because of client-side validation paradigm. So we have this type of serverless wallet that is doing full validation, and you don't need any server outside that wallet. So you just install the wallet on mobile wallet, and there is no other server maintained by the wallet creator which is required. For sure, a user will need, for instance, to connect to Bitcoin Core. This type of server will be required for Bitcoin-related functionality, but for RGB thing, you don't need any server to maintain as a wallet developer. And it may work, may not, if you don't need, but it may work with public Bifrost servers. I will explain what Bifrost nodes and servers are to reduce locally kept data size. So anonymous indexes can be moved to cloud, and these Bifrost servers, they are not created, well, as a wallet developer, you can create and run your own Bifrost server, but there could be also public available Bifrost servers like Electrum servers and so on. Unlike Electrum, you don't expose any privacy information if you connect to a public Bifrost server. The second type of wallets is a food wallet. Again, it is non-custodial, always. It is also fully validating, but this type of wallet, it requires Bifrost, and it doesn't store the client validated data locally, because the size of this data may grow up to hundreds of megs. So you have an option to move them completely into Bifrost in an encrypted way. And the third type of wallet is light wallet. It's not the same as SPV wallet. It has nothing to do with SPV. The light wallet can be either custodial or non-custodial. It is non-validating always. It requires a full RGB node on the server side. And again, there are 2 options. So first, you can have a personal RGB node on Raspberry Pi device at your home, or you can use a node provided by the wallet developer. but you have to know that you trust a personal sensitive information to this node. So if you are not using your private personal RGB node, you have to trust wallet developer that the confidential data from their RGB node will be never exposed to whoever. They can sell it or being forced by legal requirements to share with the government and so on. What kind of nodes are there? First of all, I will start with the common node. So we are doing a Rust implementation of Lightning node. We started as a hybrid node, so it's a services written in Rust that work together with a C Lightning node, and it will eventually grow up into full Lightning node. We call it LNP node. There is also a BP node, which is Bitcoin node. Right now, it's not validating node. It just indexes Bitcoin blockchain in a very efficient way using universal Bitcoin IDs, another standard we've developed with C.Decker. Potentially, it may use lib consensus to do a validation, so you don't need a separate Bitcoin Core instance. And another important part that you can make this Bitcoin VP node run in wallet if you need it, or it can be run on the server. And it also works as a replacement for Electrum server. All of them are using this LNP API with all the stuff that I was describing in the first part. Next, for sure, it is RGB node. It is not required for serverless or full wallets, because basically the wallet itself, it runs RGB node, but not as a separate process, but as a multi-thread application within the core wallet application itself. But still, it will benefit from all the data isolation and other parts. So because the wallet will continue to communicate with this RGB node through LNP networking protocol, it will be abstracted from wallet developers. I will show later that you wouldn't be actually doing zero message queue and LNP stuff. You will call the wrapper methods that will do it for you. So the integration is really simple, but important part of the story that you can get a full validating RGB node in your wallet, and you don't need to make it personal. But if you'd like to have a personal node on Raspberry Pi server or publicly available node, you can do it as well. And this node actually keeps this client validated data, ownership critical and privacy sensitive information. And the content of this data, if you lose this data, basically you will lose the RGB assets and the state of the smart contracts that you own. So you have to backup it in the same way like it backup Lightning channel state. And you can use public Bifrost servers, so you can encrypt with your private key from your seed phrase generated deterministically from your seed phrase. You can encrypt those data, upload to Bifrost server, and be sure that they will be kept by Bifrost server and you can access them later. The set of protocols that can be used to pay for that keeping services like Lightspeed and Storm. You probably heard already about that, but I wouldn't spend time right now to cover them. And there are Bifrost services. So it's a general decentralized storage server. It manages basically a key value index of encrypted, hashed, or blended blob data. It is used by RGB for a couple of reasons. First of all, if you, for instance, your wallet is offline and you would like to receive an RGB payment, you can specify this for a server which will hold the data regarding the payment for you once the payment is made by the other party. And when you become online, you can download those information from Bifrost and accept the payment later in time. It can hold indexes, as I already said, for wallets and for RGB full nodes. It's not required, but can be quite useful to reduce the size of the local stored data. It can hold an encrypted backup of RGB client validated data, and it can be paid with Lightspeed payments or Storm or LSAT payments if somebody would like to monetize this server. And of course, it can be used outside of RGB. So we think that Bifrost will be implementing a Watchtower API once it will be there, and it might be used for other general storage tasks, again, with the Storm protocol and the like. More details on this node you can find by this link. So what are the variants for RGB integrations? RGB integration. First of all, if you run a server, you can use a daemon-based integration. So you run the multiple daemons. They can even be made into elastic scalable environment. So each daemon can be dockerized into separate environment. They can interact over the network. You can build a cluster of services running geo-distributed in different geolocations with multiple instances. So it's all can be done. Or you can have a service-based. So basically, instead of having multiple daemons over the multiple instances, you have a single process or even a threads inside your host process, like a wallet application. And it is best, for instance, for mobile. Also, you can use a proxy-based model. It's mostly used for web, because right now there are more and more limitations for local storage. So if you're using a native web wallet, it wouldn't be able to store all the data. So you can create and run the RGB node in a proxy mode, so it will be operating with a web wallet that is not storing any data. And there are some other direct integration options, but they are not part of current SDK, and I wouldn't spend time on covering them right now. What is the part of the RGB SDK? First of all, it is a binaries, platform-specific binary runtime library for service-based integration, or daemon executables for daemon-based integration. In future, there will be also a WASM library for running the RGB node in browser, but it's not recommended again because of the local storage limitations. Also in SDK, you will find the Docker images, which are needed for daemon-based integration, which may be needed for daemon-based integration. There are language-specific code that allows you to run this RGB in runtime, written in Swift and Kotlin. There are class abstractions for JavaScript, Swift, and Kotlin that abstract from you all the networking on zero message queue, all IRM, and so on and so forth. And web proxy server if you are developing a web wallet. If anybody has a question, you are welcome to go on with it. No, okay. So this is the way it looks in terms of architecture and integration. So for integration, you do just RGB call, providing with some configuration object, defining, do you need to have it as a daemons, as a threads, which sub-protocols you should use, which data storage should be used, and so forth. You launch it, and then you do a single call, like pay invoice. And the daemon does everything, the SDK does everything for you. And again, it is the same way as you use the same code independently, whether you run local node or you have a remote node, or independently from which particular transport mechanism or storage you are using. So this is a stack on the right side. I have to speed up because of the time limitation. However, it details for how you don't actually need to understand that to do the integration. It's kind of internals of which components the library is consisting of, how the contracts are managed throughout it, from the wallet to the storage part, and how you can build different ways of integrating RGB. Like here you have a wallet, all the data are stored on the wallet side, with some of them can be moved to Bifrost index or not, or you can store more data on Bifrost server, or even you can make a non-custodial light wallet that doesn't store a lot of data at all. It stores the data only about the assets you own, and not client validated, but more like cached representations for user interface. And I will skip this one. So all of these integration options, they follow the same architecture. So you have a multi-threaded process or multiple daemons. These are the right part. It's actually an RGB node, how it looks like. It uses some storage. It communicates to Bitcoin and Bifrost backends if required. And your wallet or exchange or Lightning node, it communicates with this system in two ways. First of all, it sends a simple RPC requests, like do a transfer of the asset or issue an asset. And it is also reading the data from the SQLite database. So once something is changing at the backend, at the RGB node that you have on your mobile wallet, it can change not because you invoked some action. It can change because you, for instance, received some payment. So you notified about that through another zero message queue API, which is publish subscribe API type, and you retrieve the required data from SQLite database. This part I have to cover in more details. What it means, basically, the common problem with the development of user interfaces and applications is that you decide as a part of your product design or graphical design or user experience design that you have, for instance, on this screen, you need to present user with this and this information. And each time you change the information you present on the screen, you have to change the integration. Frequently, you have to change backend, either server part or storage part or data model. And it makes like adding each element and redesigning the interface is a really hard task. So instead of that, what we are doing is basically we're storing the data that are related to user interface in relational database. In case of mobile wallets, it can be SQLite. In case of exchanges, you can use Postgres or any SQL database. And basically, you run queries against those databases. So when you're being notified that, for instance, you received a payment, you are provided with ID. And you construct a SQL query and use your favorite object relation model to retrieve the data that are required for a particular screen to be updated. So if you today, for instance, have a screen listing all the assets that you have in a table, and you do one SQL request, and tomorrow you need to add on this screen not just an information about the asset, but for each asset, information about the latest transaction. All you have to change is to change the SQL request, adding some joins or something like that, and that's all. You don't need to change anything in API. You don't need to change anything in RGB node. This is done in a very simple way. And the bottom line idea is that, again, you are not actually writing the part that works with SQLite database by yourself. It is being provided by SDK. You will have a standard ORM bindings for Swift, for Kotlin. You can, of course, extend them if you need, but it's already there in the box. So as I told, the integration is done with a few lines of code. And basically, I'm showing how it works with this zero message queue data bus and also with access to SQL database. So there are two ways of how you can integrate into your wallet. You can do a high level, really simple API integration. So you send a simple request via API. Basically, you're not sending a request, you are calling a function, native function, and this function is sending the request for you. You get the success or failure. And once the actual transaction is happening, you get notified through publish subscribe interface that these entities with these IDs are changed. And then if these entities are present on your screen, you basically request to the data, to the SQLite database, you get the new entities and you redraw your screen. So it's a reactive paradigm, event-driven paradigm, and you can do practically any kind of user interface with this approach, with a few lines of integration code. There is another option if you need to go deeper into lower level. In this case, you can, if for instance, you would like to to build a very custom transaction with additional inputs, outputs, and you would like to coordinate multiple transactions, you can provide a callbacks. And this callbacks again working through zero message queue. So the RGB library will call back to your wallet in the points of customization, and you can provide it with additional data. The rest is working the same way like in the most simple case. So basically that's all for integration part. I really skipped a few slides and few details, but I think those who are doing wallets, you can contact us and we can make another presentation dedicated to the integration. I think that the first question will be about when we can start integrate. I would say that this is the first alpha release. So we're doing an internal test project, and I think it will take another few weeks for us to make sure that everything works fine. All the language we need to finalize all the language bindings, all the APIs and so forth. So it's not tomorrow, but I think you can plan to be ready to start some work with the integration of RGB into your wallets in a month from now. But keep in mind that the actual RGB will be released once the Lightning Network part will be also ready, and it wasn't covered in this part of the presentation. But also the bottom line idea is that if you need to integrate both RGB and Lightning, including Lightning outside of RGB, like normal Lightning, you can use LNP node as well, and it will work in the same way like RGB node. So the same architecture, the same way of integration, the same way of doing payment, the same way of managing store, everything is the same. So if your wallet don't have non-custodial Lightning today, you can do both RGB and Lightning together with the same simple integration architecture. Yeah, that's probably all, and let's do the quick questions.
Thank you very much, Maxim. Guys, feel free to ask questions now. I understand that it's been very fast, but still, any questions, any feedback would be appreciated. Feel free. That is a long silence.
Yeah.
So while you are thinking about the questions, I can add my 2 organizational sets. This presentation is online already. And yes, as Maxim said, you can just drop a message to us, me or him, and we could basically answer probably most of the questions or guide you through the repositories and everything when you can take a look at and digest, and probably then some questions will arise. Yeah, I can actually see, I will not point fingers, but I can see a bunch of guys that have been building wallets here. I'm actually very curious about your feedback because you're pro in that. And RGB is, like, we tried to build RGB as a very universal technology, especially for you guys. Any even preliminary and raw feedback would be much appreciated. So can you please speak up?
Single them out.
Okay, then. Yeah, there's a lot of work to do.
Okay, no, I had the microphone deactivated. From my side, yes, congratulations, Maxim. It's very, very insightful presentation, and I'll download the slide and then I'll send you in the next week all the requests for the connection point with seamless grid that which I'm going through it. So with this new slide and definition, I will ask for the integration with the project. So the point of contact, and
Thank you, sure.
Yeah, because there is much thing. Probably will regard more the asset specification, so the schemata part, but also all the communication protocol and the routing would be important. So I will drop a message to Olga and you when I will make the point.
Yeah, thanks. And just I would like to ask everybody to keep in mind that we are still very focused on finalizing all these parts. We have to do at the same time nodes, integration part, Lightning Network part, and we are just very few people. So right now we are not immediately available for integration requests, but throughout the summer we will become more and more fortunately available for all of that. So we are focusing right now on completion of the Lightning Network part and fungible assets, and after that we will be able to move to other parts of the network.
Okay.
Thanks, Fabrizio. Thanks for stepping in. Maxim, I actually have a question. I got this from one of the guys that I talked to. Is it possible to have a custom logic built into asset balance and transfer functions on RGB?
Because a custom what?
Logic built into asset balance and transfer functions in RGB. The guys there have an oracle that provides data to the supply policy of theirs. And they were wondering if it's possible to have a supply policy contract that adjusts to the global supply factor in the token.
Well, basically, it is possible to add a custom business logic with a simplicity language. So RGB supports simplicity script. It wouldn't be present in the first release, but again, it is in the specification and we have the fields for the scripting. So we will wait for Blockstream to complete their work on finalizing simplicity language, and it will be hopefully integrated down the road. So you can do very interesting stuff. For instance, you can make a asset amount of asset to be a function of time, for instance. So you can build that if you need to build some inflationary or deflationary asset, you can do it for use it for it. In terms of oracles, simplicity script wouldn't have access to the world outside of the data that are in RGB, but instead of that, you can have an oracle to be a party in RGB contract. So if an oracle will control some Bitcoin transaction outputs, you can use them to make Oracle a party of the contract. So Oracle can generate the data for some contract, and your wallet will be actually, if the Oracle will provide this data to Bifrost server, it will be able to distribute them over the network, and your wallet will be able to do some logic that requires involvement of the Oracle, and that can be evaluated even from simplicity script.
Okay, perfect. Thank you. Guys, so I offer to have like 3 minutes for Q&A session, and then we could wrap it up because it's been 1 hour and a half already.
Hey everyone, yeah, I was curious, what's the timeline for like simplicity integration? I remember I think the ETA for simplicity is end of year. So I guess is with RGB is kind of the plan to integrate it kind of an early beta version, or yeah, just curious on the timeline.
Well, we don't have any specific timeline yet, because first, before starting this, we will finish the first release of RGB with Lightning and the rest of stuff. For sure, we wouldn't be able to release it before Blockstream will complete its own work on simplicity, but I'm quite sure that the work will start over the autumn, and hope for sure we will be doing that for beta versions as well. So once we will reduce the load related to Lightning Network, that would be one of the first tasks we will move to.
Cool.
This might be a bit of a general question, but how is RGB being designed with like Taproot in mind, seeing as there are going to be lots of changes to a lot of Lightning Network and Bitcoin related protocols once we have Schnorr and all these other things?
Yeah, it is designed with a Taproot in mind. We spent quite a lot of time making sure that RGB will work with all potential further improvements for both Bitcoin and Lightning Network. So it works with the Schnorrs, Taproot, TapScript. It will be able to work with L2. It will support any potential generalization of Lightning Network, channel factories, bidirectional channels. It works with different ways of atomic swaps. So everything is there.
Cool.
Yeah, that's very good to hear. By the way, can you guys hear me? Earlier,
Yes.
Okay, cool. I wanted to come back to Olga's question regarding wallet implementations, and what I'm mainly interested in here is like a privacy-focused Lightning and RGB implementation, and of course in Wasabi this would be a great achievement here. But what Nadav earlier said, the issue is mainly with Taproot. As far as I can guess, I think that Wasabi will implement Lightning in general at the earliest with Taproot, maybe even with Zcash no input or the L2 mechanism. So I do think that just in order to save development time, it's going to be a little longer before Lightning will be implemented, just because everything changes so fundamentally with Taproot. So just for your consideration.
The interesting part is this is one of the reasons we are doing this LNP node, and we are doing it in a modular way. So unlike other Lightning nodes, this node doesn't stick to a particular message construction or particular commitment transaction structure or scripts in outputs. These are all modules. So with the LNP node, once it will be completed throughout this year, you will be able to just replace, even before the Lightning Network did that, for Zcash no input or to Taproot or to something else, extend the structure of commitment transaction, add additional outputs, do a multi-peer channels, communicate the channel structure from the day of its release. So if you will be using for a wallet integration, LNP node and RGB node, you will be Taproot ready. So why to wait until the final release if you can start doing that earlier than later?
Yeah, that is a very good point. And by the way, there were some discussions on using the Rust Lightning node for Wasabi 2 with C# wrappers. So it's very good to see that you've done a lot of work on this. So I do think there's a lot of synergies.
Yeah. LNP node is basically Rust Lightning, but Rust Lightning dissected in a way I described for networking, but it also dissected for the commitment transaction structure and so forth. So all the functionality of Lightning Network is made modular and replaceable with other version or other module.
Is it a fork of Rust Lightning, or is it an entirely separate project? And if it's a separate project, do you guys plan on mixing anytime in the future?
It's not a fork of of Rust Lightning. It uses Rust Lightning library, but it does re-implementation of many things on top of Rust Lightning. And it could be that most of it will be backported to Rust Lightning itself. So we're discussing with the guys who are doing Rust Lightning the potential refactoring and so forth. So it's kind of add-on on top of Rust Lightning, separating different APIs from each other, re-implementing some parts in a different way, but it requires Rust Lightning as an underlying structure.
Gotcha, cool.
And again, the idea, even everything we do for RGB and Lightning is written in Rust, it can be integrated from software without doing a custom reimplementation in other language, because first of all of this zero message queue API, so you don't need to encode the structure to create wrappers for each methods that you are calling. You can do a very high level abstraction in Rust again and compile that into a binary library and expose just a few methods through language specific bindings. And it's really simple. Alekos, who is probably present here, he already did that for Node.js, and it works really smoothly.
Yeah, that's actually interesting. Just a general question. What about having like wrappers around the Rust code? For example, C# wrappers around the LNPBP node. Is that possible? Is that even like does that make sense?
Yeah, that's what actually I was trying to explain, is that you don't need wrappers. In terms of LNP node, what you do is actually you have a single function that boot up the node with some configuration, and then you call this node through LNP API like RPC, and you can do that from C# or any other language. And even if you would like to simplify further and not do the actual networking part on the wallet side, you can write a Rust again. You can use a Rust library to do even this part, and then you will create wrappers for these functions that will basically abstract networking from the wallet itself.
Okay, that's great. Thank you. Yeah, so just one more thing. It's not a question of when to implement Lightning or RGB. It's just a question of priorities and development time, right? For Wasabi.
Yeah, sure. And yes, we are not 100% ready to start working with any wallet to do the actual integration. We need a bit more time before that.
Any 2 weeks now.
Yeah, kind of. Okay, guys, I think I have to run because I really outscoped the time limit that I had.
Sure. So thanks everyone for being here. Thank you, Maxim, for the presentation. And we'll be covering RGB topics over the course of next week. So stay tuned. If you have any questions, you can write them to me or in the group. Thank you and have a great day.
Thank you.
Bye.
Hey guys, I wanted to do one small announcement. I'm making a Rust workshop and I want to crowdfund it. I'm tweeting the link now and I will send it to chat. So if someone wants to improve Rust skills or on Rust, they will be able to via this workshop.
Thank you, Martin. That's very interesting. Thank you very much.
You are welcome.